Good day everyone, I am Ivy Jean Elamigo and I'm going to report example of combined axial and bending stresses. So a W10 by 45 column carries a central load and a lateral load shown in figure 18.8. Used A36 steel, Fy is equals to 248 MPa, Cm is equals to 1.0 for unrestrained, and K is equals to 1.0. Compute the allowable compressive axial stress. Compute the allowable bending stress. Is the column safe to carry the load? If so, what is the total interaction value for both axial and bending stresses? So this is the figure. So the property of W10 by 45 are the following. Area is 8,516 mm squared. D is 257.05 mm. BF is 203.76 mm. TF is equals to 15.70 mm. TW is equals to 8.89 mm. SX is equals to 805 times 10 raised to 3. SY is equals to 218 times 10 raised to 3. Rx is equals to 109.98 mm and Ry is equals to 50.8 mm. So first is we need to solve the allowable axial compressive stress. So KL over R, so substitute the value. So KL is 1 and the length of the column is 4 meters, which is 4,000 millimeter over R equals 50.8. So the answer is 78.74 MPa. Then CC is equals to square root of 2 pi squared times E over Fy. Substitute the value. So square root of 2 pi squared times 200,000 over 248. So CC is equals to 126.17, which is greater than 78.74. So the axial compressive stress will be computed using the formula. So kani. So the quantity of 1 minus KL over R squared over 2cc squared times Fy over Fs. So, since so pantay value sa Fs, so ato sang pangitaon. So, for that, so muna siya ang paagi. So, 5 over 3 plus 3 times 78.74 over 8 times 126.17 plus 78.74 squared over 8 times 126.17 squared. So, Fs is 1.87. So, since na naman tayo sa Fs, so masolve na nato ang compressive stress. So, i-substitute rin nato ang value. So, the answer is 106.79 MPa. Then, next is allowable bending stress. So, LB is 4,000 mm for unbraced length ni siya. Then, LC is equals to 200 times BF over square root of Fy. So, kaning BF kay na naman is sa katong properties sa katong column. So, substitute the value. So, 200 times 203.76 over square root of 248. So LC is equals to 2,588 millimeter. Then LU. So ang LU masolve na siya gamit kaning formula. So 137,900 over Fy times D over BF times DF. So kani silang duha naagyapon ni didto sa properties. So substitute the value. So ang atong LU is equals to 6,920 millimeter. So since ang atong LB is greater than LC but LB is less than LU, so the formula for the bending stress, compressive bending stress is 0.6 times Fy. So ang atong Fy is equals to 248. So FB is equals to 148.8 MPa. And then the third problem is total interaction value for both axial and bending stress. So aron ma-determine nato if ang load is if ang column safe ba to carry the load. So first is submission of moment at A. So dito sa figure mag-moment ta at A. So 4 times R2 plus 90 times 0.3 minus 20 times 2. So Rn is equals to 3.25 kilonewton and R2 is equals to 3.25 kilonewton and R1 is equals to 20 minus 3.25, so equals 16.75 kilonewton. Then the maximum M is equals to 16.75 times 2, so it is equals to 33.50 kilonewton meter. So to solve the axial stress, so FA is equals to P over A. So substitute the value, so 450,000 plus 90,000 over 8,516, so FA is equals to 63.41 MPa. Then ang atong axial compressive stress is 106.75 MPa. So FA ang axial stress over axial compressive stress axial stress over axial compressive stress is equals to 0.593, which is greater than 0.15. So use FA over FA plus CM times FBX over the quantity of 1 minus FA over FE prime X times FBX. So it should be less than 1.0. So mo ni sila ang katong naa sa NSCP specification for axial compression with bending. So first is solve the FBX. So to determine unsa na ang value, so is ang M over SX. So i-substitute ang value. So ang atong M kay mo naman ni. So FBX equals So FBX is kuan na kani siya 33.5 nasayo pa na. So 33.5 times 10 raised to 6 over 805 times 10 raised to 3. So FBX is equals to 41.61 MPa. And then FA prime X. So para ma-solve na, so ang formula is 12 times pi squared times E over 23 times KL over R X, so squared. So diba kanina naman tayo value ingani, so ato rin substitute. So KL over R is equals to K is 1 times ang L kay 4, then ang R is 109.98. So ang gamito na pud nato nga R is katong di ba kay kaganiha ang atong gigamit kay 50.8. So ang karon ang Rx na pud atong gamiton. So morning 109.98 atong gigamit sa R. And then sa atong KL over R is equals to 36.37. So F prime X is equals to 12 pi squared times 200,000 over 23 times 36.37 squared. So F prime X is equals to 778.57. So the magnification factor is FA over FA plus CM over 1 minus FA over FA prime X times FBX over FBX, so less than or equal to 1.0. So mo na siya ang formula sa magnification factor. So i-substitute ang mga value nga nila tanan, so it is equals to 0.898, which is less than 1.0. So it is safe. So since kuan man safe man siya, so ang atong column is safe siya nga mo carry ing atong load nga gi-apply. And then for problem number 2, so a steel column section carries an axial load of 1,784 kilonewton and a clockwise moment of 272 kilonewton at the top and a counterclockwise moment of 272 kilonewton at the bottom. In the plane of loading, there is no bracing and column is subjected to sideway. Use Kx equals 1.92 and Ky is equals to 1.0. Fy is equals to 248 MPa and Es is equals to 200,000 MPa. So mo ni siya ang figure. So properties of the steel material. So mao ni sila ang properties sa katong column. So the problem is so we need to compute the allowable axial compressive stress. So kx times lx over rx. So, same man sa paagi ganiha. So, substitute the value. So, ang kx kay naaman given man sa problem, di ba? Given naman, so, substitute ra diretso. So, 1.92 times 5,400 over 162.56. So, the answer is 63.78. Then, ky times ly over ry. So, ky is 1.0 times 5,400 over 101.60. So, the answer is 53.15. So, kuan man mas dako man ni siya, so ang atong gamiton nga KL over R is 63.78. So for CC, so it is equals to the square root of 2 pi squared times E over Fy. So substitute the value. So CC is equals to 126.17. And then FA. So ang FA is the axial compressive stress. So, same sa pamaagi kaganiha nga wa may Fs, so ato sang pangitaon ang value sa Fs. So, Fs is equals to 5 over 3 times 63.78 over 8 times 126.17 plus 63.78 squared over 8 times 126.17 squared. So, Fs is 1.84. So, Fa, so substitute na nato ang value sa Fs. So, ang atong Fa na karon is 117.56 MPa. So, mo na ni siya ang kadtong allowable axial compressive stress. And then, the allowable bending stress na pod. So, same sa pamaagi na pod kaganiha. So, LC is equals to 200 times BF over square root of Fy. So, Fy nato kay 248 man. So, LC is equals to 5,016 millimeter. Then, LU equals 137,900 over Fy times D over BF times DF. So, LU is equals to 137 times 900 over 248 times 381 over 394.9 times 30.18. So, LU is 17,397 millimeter. Then, LB nato is 5,400. So, since LB is greater than L1, which is 5,016 millimeter, then LB is less than LU, which is 17,397 millimeter. So, use FB equals 0.6 Fy. So, substitute the value of Fy, which is 248. So, the bending stress is equals to 148.8 MPa. And then, for question number 3 is the checking the adequacy of the column section. So, first is the to do is the interaction value, determining the interaction value. So, cm nato kay 0.85 kay subjected to sideway man, sidesway. Diba kay indicate man sa problem. So, So, ang atong cm is 0.85. So, the actual stress is P over A. So, substitute the value of the load, which is 1,784,000 over 29,999.94. So the actual stress is equals to 59.47 MPa. Then FBX equals M over SX. So FBX is equals to 272 times 10 raised to 6 over 4,146 times 10 raised to 3. So FBX is equals to 65.61 MPa. Then actual stress over actual compressive stress equals 0.51, which is greater than 0.15. So, kira na siya. So, use FA over FA plus CM times FBX over 1 minus FA over FE prime X times FBX. So, it should be less than 1.0. So, FA prime X is equals to 12 times pi squared times E over 23 times KL over R squared. So, substitute the value. So, 12 pi squared times 200,000 over 23 times 63.78 squared. So, it is equals to 253.17. So, the magnification factor should be Cm over 1 minus Fa over Fax. So, equals, so the value of Cm is 0.85 over 1 minus 59.47 over 253.17. So, Cm over 1 minus Fa over Fa prime x is greater than 1.11. So, kani siya is equals to 1.11. So, it is greater than 1.0. So, okay ra na siya. So, diri na punta sa FA over FA plus CM times B FBX over 1 minus FA over FA prime X times FBX. So, less than, so it should be less than or equal to 1.0. So, i-substitute na ito ang value ng itanan. So, matong CM is 1.11 times FBX is 65.61 over 148.8. So, it is equals to 0.995. So, since less than man siya sa 1, so safe siya. So, kung ano, i-check pod nato ang FA over 0.6 FY plus FPX over FB. So, kanin sila dapat less than po siya sa 1. So, substitute ang value. So, The answer is 0.84, so less than gihapon siya sa 1, so safe gihapon. So therefore, since safe man sila tanan, so the column is adequate to carry the load. So that's all. Thank you.